All right, we want to talk today about triangles. And before we talk about triangles, I need to review some angle terminology with you. We want to remember there are three different kinds of angles that we can make when we connect two rays. So we're going to draw some angles right now, beginning with a right angle, which the right angle, I hope you remember, is the one that is 90 degrees. A 90-degree angle is a right angle. So there's my first ray, or line segment in this case. Oops, that's not. There's 90 degrees. Okay, so now I have a 90-degree angle, and you can see right here it was 90 degrees, and we can mark it with a square. Remember also, you can have an angle that is less than 90 degrees. So let me bring back the ruler. And so this is 88 degrees. I could come all the way down to 1 degree. All of these different angles that I'm making right here are acute angles because they are less than 90 degrees. And I'm going to just draw a little line here to make my acute angle. Okay, and I'm going to draw my arrows because these are supposed to be rays. So here's an acute angle. It is less than 90 degrees. So less than 90. This one is 90, so that one equals 90. Now there's a second or a third type of angle, which if you will recall, I'm going to move my ruler over. The third type of angle is the one that is greater than 90 degrees, and we call that one an obtuse angle. An obtuse angle. So I'm going to make it going this way. So here's my obtuse angle, and if you'll notice, well, my little protractor, or my little angle measurement on the side here doesn't really show you very well, but this is my obtuse angle right here. Turn off my ruler and I can draw you the little arc that shows the angle is an obtuse angle, and it is almost 120 degrees. Maybe actually a little more than 120 degrees, the way I drew that. So that's 120 degrees, and that is more than 90. That makes it obtuse. Quick little way to remember this. Right angles have the square. Okay, they are the ones that are 90 degrees. Right angles are 90. Acute angle is a cute little angle, and it's less than 90 degrees. Remember that acute angles are little bitty angles, or less than 90 anyway. And obtuse angles are great big angles. They're the ones that are bigger than 90. All right, so now we're armed with a review of angle measurements. Now I want us to go back and look at our textbook. And we have triangles that can be classified in 6 different ways. And these different ways actually overlap because you can have a triangle that is classified by either the length of its sides or the angles of its vertices. So let's first look at the sides. We'll just look at sides right quick. The sides of a triangle, if you have 3 congruent sides, 3 congruent sides means that you have a three congruent sides means you have an equilateral triangle. Lateral refers to the sides. Equal means they're equal. They're all the same. So this one has 3 inches, 3 inches, and 3 inches. And we show that they are congruent with these little slash marks here. An isosceles triangle has only 2 congruent sides. And again, you can tell that they're congruent because we put these little slash marks here to show that they are congruent. Don't just eyeball it and say, well, they look about the same. No, if it doesn't tell you that they have equal measurements or that they have these slash marks to show congruency, do not assume they're congruent. But in this case, we're telling you these 2 sides are equal. Therefore, it is isosceles. And a scalene triangle has 0 congruent sides. Every single side is a different length. So here's one that's 3 inches, here's one that's 4, here's one that's 5. So that's one way that we can classify triangles, by its sides. But there's another way, as we said, by the angle. So we look over here, a right triangle has one 90-degree angle. So here it is. There's your 90-degree angle, and it's one right angle. So therefore, we can call this a right triangle. Okay? Now, a right triangle could be a scalene triangle like this, because this one actually happens to be a right triangle. Or a right triangle could be an isosceles triangle, because if I took this and I extended the legs a little bit so that they are congruent, see, there's still a right angle and 2 congruent sides. So a right triangle could be isosceles or it could be scalene. But it cannot be equilateral. Okay, well then we have an acute triangle. An acute triangle has 3 acute angles. 3 acute angles. So here you see them. There's 30 degrees, 75 degrees, 75 degrees. None of those is more than 90 degrees. None of them even equals 90 degrees. So the acute triangle could be an equilateral triangle. It could be an isosceles triangle, or potentially it could even be a scalene triangle. If, say, this was going this way and it were, I don't know, 2 inches, then that would make it an acute scalene. So acute triangles can be either equilateral, isosceles, or scalene. Now then we have the obtuse triangle. The obtuse triangle has the one great big angle, which is 130 degrees in this case. So it has one obtuse angle. And just like the right triangle, if I were to extend the leg a little bit so that it has 2 congruent legs, it could be an isosceles triangle, or if I left it like it was originally, it could be a scalene triangle. So one way that I think about scalene triangles is that when all the sides are different, it kind of looks like it leans one direction or another. So a scalene triangle kind of leans. An equilateral triangle is all the same. Now notice the equilateral triangle can only be an acute triangle. That's the only way you can have an equilateral triangle. Okay, so we have 6 different properties that we can look at, and they can be combined to give us a very specific description of our triangle. So what you're going to do is you're going to be practicing classifying some triangles, and we'll do that in class as we work on our paper airplane project. So look at some practice problems on this, and we will put this concept to application with our paper airplanes on tomorrow. Have a good